Is absent today?
Saurat.
Only Saurat is absent, right? In previous period, there was exercise discussion. Now there is presentation from student side. All right, and later on I will discuss about those things and I will give you some facts. Is that okay?
Yes.
So it's a turn of first presentator. A name is already given here. Ritika Maharjan. Let's welcome her on the stage.
Namaskar everyone, as you all know, it's Ritika Maharjan standing here to give presentation on the chapter Wave. There are different types of wave: natural light source and artificial light source. Wave refer to the path of energy, all type of energy transmit from one point to refers to the path of energy, all type of energy transferred from one point to another in the form of waves. Light and sound also move from place to place. Wave refer to the path of energy. Size matters when it comes to describing waves. It sets the stage or the sense moods. Is the wave during and intimidations or small and playful. The size of a wave can convey emotion from tranquility to terror. Reflection of wave. Sound energy and light energy are very familiar to us. Like other sources of energy, they also propagated in the form of wave traveling at different speeds in different medium. To illustrate the concept of wave refraction, like consider a light wave. From example, the speed of light in air is maximum, while in water it is slower than in air. Similarly, the speed of light in glass is higher than in water but flow lower than air. To illustrate the concept of wave refraction, let's consider a light wave. For example, the speed of light in air is maximum, while in water it is slower than in air. Similarly, the speed of light in glass is higher than in water but lower than in air. Refraction of sight, refraction and sight. The Brogan principle side. As light travels through a given medium, it travels in a straight line. However, when light passes from one medium into a second medium, the light path bends, refraction takes place. The refraction occurs only at the boundary. Once the light has crossed the boundary between the two media, it continues to travel in a straight line. Only now the direction of that line is different. That is what in the from medium. If when sighting at an object, light from that object changes media uh, on the way to your eye. A visual distraction is likely to occur. This visual distraction is witnessed if you look at a pencil smart in a glass half filled with water. As you sight through the side of the glass at the portion of the pencil located above the water surface, light travel directly from the pencil to your eye. Since this light does not change medium, it will not refract. Refraction of light in a glass slab. When a ray like AO in air is incident on the surface PQ of a glass slab, the ray bends along a OB in the glass slab A as shown in the figure. Mn is the normal to the glass surface. ATO. The ray OB when uh, we- uh, the ray OB then emerges along BC in air, where AO is an incident ray and OB is a refracted ray. The incident ray AO makes an angle AOM with the normal MN drawn at the point O, which is called angle of incident. Refracted ray OB makes an angle NOB with the normal MN, which is called angle of refraction. The incident ray AO makes an angle AOM with the normal MN drawn at the point O, which is called angle of incident. Refracted ray OB makes an angle NOB with the normal MN, which is called angle of refraction. Rare and denser medium. The medium in which the speed of wave is more is called a rare medium. On the contrary, the medium in which the speed of wave comparatively less is called denser medium. The medium through which the light passes is called an optical medium. Air, water, and glass are few examples of optical medium. In air, water, and glass, the speed of light is 3 into 10 power 8 meter per second, 2.5 into 10 power 8 meter per second, and 2 into 10 power 8 meter per second respectively. The speed of light in air and vacuum is considered equally, that is 3 into 10 power 8 meter per second. Every time we pick up a glass of water, we witness a fascinating phenomena that highlight the difference between denser and rare medium. What is a denser and rare medium? Have you ever noticed how a straw placed in a glass of water appear bent at the surface? This is intriguing optical illusion occurs due to the varying refractive indices of water and air. It is just one example that showcases the impact of medium density on the behavior of light. In this article, we will explore the concept of denser and rare medium, their characters, and how they play a vital role in understanding the interaction of wave and light with different substance. By understanding these fundamental aspects of optics, we can gain a deeper understanding of the world around us and the behavior of light in different medium. Cause of refraction of wave. The speed of a wave is generally different in various medium. When a wave transmits from one medium to another, its speed undergoes change. This alternation is the speed of the wave is the primary cause of wave refraction. Thank you.
Okay, very lovely, lovely. Thank you, Arya. So if you come near to this, we afraid also, right? Anyway, so she presented up to cause of refraction of light. Then next one, what is there? A denser medium, rarer medium, right? Actually, what is given here? Denser medium, rarer medium. Here, rarer medium, denser medium. Whatever difference can you find here? Denser means having more density, less speed of light. Rarer, less density, more speed of light. Here is given, when a ray of light travels from denser to rarer medium, it bends away from the normal. Here is normal going away from normal. Pay attention, eh? Ray of light going from denser to rarer becomes wrong. When the ray of light goes from denser to rarer, then what will happen? It bends towards the normal. Okay, it bends towards the normal. But next one, when the ray of light goes from rarer to denser, then it goes away. Okay, this thing we have to remember. Why? Because density I think it was okay. This figure is okay. Goes from denser to rarer. Why confusing? Denser to rarer means speed will increase or decrease. If it increases means it goes away. That was right. Give a big round of applause. Sometimes confusion. So when goes from denser to rarer means speed increases, goes away. Here, rarer to denser means speed decreases towards this one. No. So yesterday also we discussed in between water and glass, which one is denser and which one is rarer? Between water and glass.
Sir, rarer is glass, denser is water.
Oh no, wrong. Denser is glass, rarer is water. The density of glass is more, density of water is less, isn't it? More density, denser, less density, rarer. Speed of light is more in rarer, less in denser. These things we have to remember. And next thing she said, cause of refraction of wave. Why the wave refracts, bends? Main thing is speed of the wave in different media is different. The wave does not travel in all media with same speed. In solid, it travels with less speed. In liquid, travels with more speed. In gas, travels with much more high speed. That is the case of light. But when we talk about sound, sound travels fastest in solid, a bit slow in liquid, very slowly in air. Remember, opposite is there, right? That means the speed of wave differs in different media. Because of that, the wave refracts or bends. So, okay, so she has already said thank you. Now, let's welcome on the stage our next presentation, none other than Jai Kumar Sharma. Sharma is a Shram, right? Are you Shram or Sharma? Then why? What did you see here? While typing also it became. This is not printing mistake, it's typing mistake. Right? Maybe it's speaking mistake also. Nowadays we can type with our mistake. Our sound.
Namaskar everyone. I am going to present presentation on the topic of wave. Some example of refraction of light. Refraction of light at the air interface. So when a pencil is immersed in water, it appears to be bent. This is because of refraction of light. When light passes from a denser medium to rarer medium, it bends. That's why it is appear to bend, but actually it is not. So other example of refraction are a fisherman targets to a fish as it is seen in water, but the fish escapes. The legs of a person seem shorter while standing in a swimming pool. Kingfishers dive straight down to catch fish from the lake. Clear water ponds appear shallower than its real depth.
Down here again. Now down here again. Pardon, only one or what? Might be only one slide.
No, sir.
Okay. What?
Consequences of atmospheric reflection of light. The light from star passes through the atmosphere before reaches the observer on the earth. The atmosphere is not static. There are always currents of hot and cold airs. These hot and cold layers create difference in densities, due to which the phenomena of bending of light occurs, due to which the twinkling effects of star is seen. Reflection of light causes advanced sunrise and delayed sunset. Due to atmospheric reflection, we can observe the approximate sign 2 minutes before and after the actual sunrise and sunset. The rays of light emitted by the suns are refracted towards the ground while traveling through the optically rarer layers of air in the atmosphere, especially when the sun is slightly below the horizon. Now, laws of reflection. Laws of reflection of light occurs when it travels from one medium to another. It obeys the following laws. The incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. The figure is not given, but you can see in your book. In figure, the incident ray AO, the reflected ray OB, and the normal MN lies on the same plane at the point of incidence O. The ratio of sine of the angle of incidence to the sine of the angle of refraction is constant for a given pair of mediums. This relation was propounded by Willibald Snellus, a Dutch astronomer and mathematician. So this is called Snell's law. You can see from this, m constant is equals to sine of angle of incidence, sine 1 divided by sine of angle of refraction, sine r. When a light ray travels from a rarer medium to a denser medium, it bends toward the normal. It means the angle of incidence is greater than the angle of reflection. When the light passes from a denser medium to a rarer medium, it bends away from the normal. It means the angle of incidence I is smaller than the angle of reflection R. Thank you.
Thank you very much. So, children, what you have to do, you have to be focused on diagrams in this chapter. So, what was discussed, let's see here. Is your class 10's book? Is your class 10 book? Which one is class 10 book? This is a class 10 book. So, in daytime we have discussed. Yesterday we have discussed this portion also. Just now it was given like this. Denser to rarer, away from the normal. Rarer to denser, towards the normal. And see here, because of reflection of light, it seems bent, little bit bent. In this side only, not inside the liquid. Where it is the point of contact, it seems reflected one or bent one. Examples are given here. And see, what is next one? Twinkling of stars. Star is far away. And there are different layers of air here in that atmosphere. That's why whenever light falls on it, slowly bending, it comes. That's why it seems as if twinkling. But the stars in reality, they don't twinkle. So for that, we have to go near about 20 kilometers up from our surface. 20 kilometers, because 99% of air is located in troposphere. The lowest layer of air is called atmosphere, is called troposphere. Only 1% is up, and from there we can see only those stars not twinkling, just giving light straight one. Okay, so this is because of refraction. And next one is here, reflection light cause advanced sunrise, and advanced sun rises quite fast and sun sets a bit slowly because of that also. Mainly this law of refraction we have to remember. What do we discuss? Laws of reflection. Not reflect. We have to say, okay. Refraction. Fraction means changing into a smaller portion. But here it doesn't change, it just bends, isn't it? So here is glass slab. This is incident ray. What is this? What is this? Refracted ray. And what is this imaginary line? Normal. So how many laws of refraction are there? 3 laws of refraction. What are they? First law, second law, and third law. What does first law say? Incident ray, refracted ray, and normal at the point of incidence. Point of incidence means where they are touching, they lie on the same plane. That is number 1. Is incident ray, refracted ray, and normal, they lie at the same plane. Number 2, angle. So what is this angle called? Angle of incidence. What is this called? So sine angle I upon sine angle R equals to constant. We write it as mu. Mu. What is this? Mu. Greek letter mu. We write it refractive index. What is it called? Refractive index. So one formula of refractive index is mu equals to sine angle I upon sine angle R. Remember this thing. Sine angle I upon sine angle R. Okay, and this was propounded for the first time by one scientist. What is his name? Wilbrod Snellis. Wilbrod Snellis. So it is called Snell's law. What is it called? Snell's law. Pascal gave law. Pascal's law. Archimedes gave law. Archimedes' law. Newton gave law. Newton's law. Right? If Mr. Neopani gives law, Neopani's law.
Yes.
If Saha gives law, then Saha's law. Right? In that way. But here, Snell's law. Now, next thing is here. Next point. What is the next point here? When a light ray travels from a rarer to denser medium, try to understand here. What is given here? Rarer to denser medium. Then it bends towards the normal. Yeah. Yeah, when it goes from rarer to denser, rarer to denser, bends towards the normal. Your angle I is bigger than angle R. Rarer to denser. When it goes from denser to rarer, then it bends away from the normal. Angle I is less than angle R. Okay? And if it strikes perpendicularly, then it does not deviate, it does not bend. If angle of incidence is 90 degree, it does not bend. If angle of incidence is less than 90 degree, it bends. These things you have to remember. These are the three laws of refraction of light. And here is one, this diagram also, this one activity. Okay, next day we will be discussing about other portion. Which duty is there? Susmita, and next Srijal, next. Okay, Purnima. Oh, she doesn't belong to that group. Okay, so now take out your book, read once again, then I will give you some lollipops. Okay, come on.